This is the memory allocation and garbage collection activity in Java. I have the folder open here along with the README file. We'll run through this really fast. The first point here is to research memory allocation and garbage collection for Java. So if you have not already done that, please do that now. Pause the video, go do research in your favorite search engine or your favorite AI tool. See if you can do some research, take some notes, try to figure this out. We're going to address these questions down below. So objects, how they're allocated, how they're deallocated, the difference between managed and unmanaged objects, ensure the deallocation of unmanaged objects. Are there specific design patterns or specific types in the language that can support us, and how can you interact directly with the garbage collector? So to help us out, let me just create a file here. We're going to create a new file, myfile.java, and let's just create a class. We'll do public class app, and let's do a public static void main, and we'll do a public static void example. And main will just call into example. And then let's see, what do we want to do here? Let's do a private static int my value equals 3. And then we'll do var a equals 2.0, var b equals test. Let's do a for loop, so for I equals 0, I less than 2, I plus plus. We'll do a system.out.println I. And let's just print out B. So we use this code to help us talk through some of these questions here. So let's start off with how are objects allocated in memory by a programmer. Allocation happens automatically along with deallocation. The objects are allocated as it finds either object literals or inline literals or the new keyword, so constructors. So our inline literals, we've got 3, which is an inline literal for an integer. We've got 2.0, which is an inline literal for a double or a floating point. We've got double quotes, test, which is an inline literal for a string. There's also inline literal for Boolean. So there's several different inline literals that we're going to be able to see here. Any of these are inline literals. An object gets created for each of those values and put into memory. In addition, if we create an object with a new keyword, so let's say new connection here, the new keyword, the constructor, creates an object in memory and places those values into memory at that time. So again, the new keyword, so the constructor, as well as the object literals, are when values actually get allocated into memory. For deallocation runs in terms of scope blocks, very similar to the other languages. So the scope, where a value is defined or where an object is defined, is going to determine when it's available for garbage collection. This value here, for example, 2.0, the value will be, or the object will be eligible for garbage collection when the scope in which it's declared is completed. It is declared inside the scope for the example method, and the scope is defined by the curly braces. So it starts on line 7, ends on line 16. So 2.0, that object is available for garbage collection on line 16 once it gets to the completion of that scope block. So when we call example from line 5, all of these values are going to be eligible for garbage collection when example gets finished, once it comes back to the main method. I, on the other hand, is declared inside this for block. So that's a separate scope block, which means I is immediately eligible for garbage collection once the loop finishes. So we can still be inside the example method on line 15, but I is now out of scope, and therefore it is eligible for garbage collection. What is the difference between managed and unmanaged objects, and how can you ensure deallocation of unmanaged objects? So the long and short of this is, in Java, you generally don't deal with unmanaged objects. You can. There's a way to do it. I'm not going to go into that because it's really, really not common and it's discouraged. If you needed to do this, I would suggest do some internet research on it or ask me another time, but I'm not going to go into the unmanaged types of objects in Java. The next question, are there design patterns or specific types in the language that can assist in garbage collection? The answer is yes. So there is a closable interface and an auto-closable interface in Java. If a class implements one of those, it'll have a close method, and we can then use that object in our code with a try block. So for example, if there's something like database connections are often this way, file streams are often this way. So let's take the database connection, for example. What I can do is I can say try var connection equals, and usually you might use like the driver manager dot get connection and with the URL, and I'm not going to type all this out, but effectively what's happening here is this try block is going to automatically close connection when the try is done. This is the one time in Java we can use a try block without a catch or a finally. You can still add a catch or a finally on there. That's totally fine to do, but you don't have to. What this turns into is the equivalent of this code here, where we're going to say var connection, try, and then whatever code goes here, do something. This would be the same that goes here. And then down below we say finally connection.close. So this finally with the connection.close, all of this code is the exact same as declaring it inside a try scope, where we have the parentheses and the variable declaration of the thing that we need to auto close. So again, whatever this variable is, whatever this object is, needs to implement either the closable or auto closable interfaces in Java, and then it will turn it into this code for us. We don't actually see that code, we just see it much more concisely. So that's the answer to that question. There is a pattern that's available to us along with a couple of types that we can use to clean up code whenever we have something that's closable or auto-closable. And then finally, how do you interact with the garbage collector directly? I'm gonna let you do some research on this. There is a way to do that, to suggest that we should run the garbage collection. It's generally discouraged. And even doing that, all we're doing is requesting that the garbage collector run. But there is a way to do that. I'm not gonna go into that for this exercise, because again, if you need to do that, you probably have other issues. So it's best to make sure you don't need to interact with the garbage collector directly, but there is a way to do that, and that is worth researching just so you understand what that looks like in the Java community, in the Java environment. That concludes the memory allocation and garbage collection activity in Java.